Good morning, everyone, and thank you for joining us for today's webinar, Using AMI Data to Provide Situational Awareness to Grid Ops, sponsored by OSIsoft. My name is Lauren Calloway, Senior Editor with T&D World, and I'll be your moderator today. Before we begin, a few words about this webinar technology. This platform allows our audience to be more involved with the presentation and, more importantly, allows you to watch this event the way you want to watch it. To begin, feel free to customize your webcast console. You can move windows around by dragging on the title bar or resize your windows by clicking on the lower right corner of any window. You'll notice a toolbar at the bottom of your console. These buttons allow you to open and close widgets on your screen. And if at any time you experience difficulties with the audio or advancing of the slides, simply press your F5 key to refresh your webinar console. We encourage you to ask questions at any time using the Q&A widget on the left side of your screen. We'll address as many audience questions as possible at the end of the presentation. We greatly appreciate your feedback, so please click on the survey icon and complete the form at the end of the webinar. And now I'd like to introduce today's presenters. First off, we have Kevin Walsh. Kevin Walsh is OSIsoft LLC's Industry Principal for Transmission and Distribution. Kevin is engaged mainly in transmission, distribution, smart grid, and AMI areas. He has over 20 years of experience in the utility space, covering areas in demand-side management, retail operations, software supporting central markets, complex billing, meter data management, and smart grid applications such as DER, microgrids, and PMUs. He works with product management development to support new functionality in this area of responsibility and field sales for applying the PI technology to assist in the new utility challenges that many face. Kevin previously worked at SAP and Ariba T&D. He holds a bachelor degree in mechanical engineering. And next up, we'll have Dan Garvey. Dan Garvey is PowerRunner's Director of Sales and Marketing and leads the company's direct sales and channel sales efforts and strategic partnerships with OSIsoft, NVIDIA, and Dell. Dan has over 25 years of diverse energy industry experience, beginning as an engineer with Boston Edison, Eversource, and the U.S. Navy, and then in the business development roles with Southern Company Energy Marketing, Siemens, and Oracle Utilities. His diverse experience from the meter to power plant supports the consultative approach that is necessary to deliver software solutions to utilities and other energy market participants. Dan graduated from Merrimack College with a BSEE. So with that, let us begin, and I'll hand it over to you, Kevin.
Thank you, Lauren. And good morning and good afternoon today. This is Kevin Walsh from OSIsoft, and again, thank you for attending. Quick slide to ground set who OSIsoft is. We are the maker of the PI system. We were founded in 1980. We got over 19,000 plus installations of the PI systems. We make one technology, and that's the PI system, and it's used over multiple verticals. We're about 1,400 employees, 27 offices around the world, and we're still privately held. Our major verticals that the PI system is utilized in is power and utilities, oil and gas, pulp and paper, metals and mining, chemical, petrochemical, and pharma. But due to the Internet of Things, we are branching out more into transportation, discrete manufacturing, and data centers and facilities. But with OSIsoft, my focus is the vertical of transmission, distribution, and smart grids. It's actually been an exciting ride. I've been here for 12 years. It's never been a dull moment, especially with our technology, the PI system, how our utilities clients pull us into different use cases across the enterprise. And as you know, who's driving us is the driver of disruption. Everybody should be familiar with what's happening with the grid. Over the last 10 years, it's been kind of modifying itself. First with smart meters, but definitely smart grid goes beyond smart meters into the distribution space and now involving the consumers, which are converting to prosumers. And that's driving a lot of havoc on the distribution network. So some of the initiatives outside of the PUCs getting involved, but the advent of smart meters being applied, distribution energy resources going down on the distribution level with customers, and customers with their batteries, electric vehicles, their storage, and then also utility solar programs. So the landscape is changing, and it's changing at different speeds across the nation, depending on if you're on the East Coast or West Coast, but it's definitely advancing. And part of that advancement is why we're actually speaking out today, to let you know that OSIsoft, the PI system, traditionally was in generation, transmission, TSOs to RTOs, ISOs, also around the modernization of the substation and just DMS. All this generates more and more data, which generates more and more complication. And then how do you take that data and transform it into information? So the focus today is more around the distribution grid ops. How do you take a space that's typically been a sleeper, and now we're adding so much more devices and two-way connectivity on that network, which wasn't designed that way? How do you make sense out of that? How do you grab that data, and how do you drive value from an operations perspective? So with the help of partners are a big ecosystem within OSIsoft, where we're working with PowerRunner to solve that challenge of getting more value out of that data that's happening on the distribution grid. Again, a picture is 1,000 words, but as you think about how the market's evolved over the years from wholesale power to the transmission and the transmission markets, now we're actually pushing down on the distribution space, where we've got clients using PI for smart meter data, sexualizers, fault sensors, mating it with not only utilizing the technology in the PI system, but also with other partners such as PowerRunner and Esri to drive that situational awareness. So as we keep modernizing the grid, it actually expands itself. It's like it's a self-capsulated Internet of Things. It's just exponentially growing with data streams and devices, as you can see. So I'd like to thank EPRI for this picture. A picture's 1,000 words. It's definitely growing, both from the smart generation on the grid to residentials and how they're taking advantage of the new technology and be able to interact with the grid. And then, you can look at what the large C&I were doing over the last few years with, partnering with the utility and being able to take advantage of demand-side management programs and other programs for the C&I. All this is creeping down into the distribution space. But situational awareness is key, especially given what's happening today. Everybody's working at home. We've got smaller staffs on site, but we still need to run the grid. It's the backbone of the economy. And situational awareness for everybody to understand what's happening, from maintenance to asset management to planners, the shifting of the loads is very important. And PI does that, right? It's the industry leader of real-time data infrastructure. It drives situational awareness outside of operation. And typically, our clients who embrace the technology, it becomes a single source of all operational, non-operational data for the enterprise. It's the place where everybody will go to get their near real-time data so they can actually perform better within their frontline business, within asset management, maintenance, and other areas. And then there's PowerRunner, which you'll hear from Dan Garvey a little later, but they bring on the IT and the data governance and the data virtualization layer, which is really going to be critical when we start going OT and IT data sets when we want to look at the distribution grid. They also, very similar to PI, bring a configurable business technology layer to the subject matter experts. Both companies believe that, if we can bring and deliver the data in a user configurable business layer, that's the best place to do it for real time. We got to run the grid in real time and support it in real time. So what are the baseline needs to support tomorrow's grid? Performance and scalability. As I mentioned and as I've shown, the numbers are going off the chart with the amount of meters being installed, amount of smart devices being installed. Think about all the time series data that's being generated. How do you harness that information from a performance and scalability point of view? Pi is one of those technologies, which is it's geared around that operational data, that time series data. Very important. And then with PowerRunner, we'll be able to expand virtual cubing the distribution grid with other data sets outside of what Pi typically houses for our customers. Data governance and data management are key in this, right? Data governance from making the data available, making the data usable, and making it consistent. We want to make sure we all use the same data set so we all drive to this common cause. And data management. We need to make this data, although it's the mass amounts of it, we need to make it accessible. We need to be able to do integration, not just from the OT side, but from the IT side. We need to make sure it's cleansed, and we talked about the data governance around it, and we need to be able to store it in a manageable environment. And then we need to prep it for analytics. Contextualization. Time series data is just a timestamp and a value. What does that mean? Well, when you aggregate the time and the value together, then you bring information around it, it adds tons of value to that data stream. So if I need to understand a meter and the relationship with that meter to the network or to the customer or to what rate class, that's all contextual information that's valuable that we need to bring together with the data set. And then there's business user configurable. We strongly believe the front line, the maintenance, the distribution engineers are the subject matter experts. We believe that if we can bring this data to them in a business user configurable environment, they're going to unleash the value of that data tenfold and be able to improve the efficiency in their business and their job and actually the resiliency of the grid. So that is our goal between Pi and PowerRunner, is to bring this down into the business where it's manageable, it's user configurable, and it's actionable. So if you think back, let's do the time warp. We're going to go back 10 years when people were investing in AMI. You know, it's like people referred it to, it's like installing another power plant. It's expensive. You've got your smart meters, you've got your communications, you've got your maintenance, you've got your technology. And people are investing in that for meter to cash. It's very important to get your cash register going and collecting data. Understand that. But the value of that data set adds just as much or maybe even more to operations. How do you get it in operations? How do you take advantage of that? So typically Pi is, as I mentioned, is the de facto operational data manager store for the enterprise. That's the go-to place where all the different business units would go and get the near real-time data for their own business purposes. But what's happening now is that, you know, most people think of Pi as a natural place where the smart meter data would be housed and stored. But it actually brings in a different set of information needed, hence we're partnering with PowerRunner to expand the capability of OSIsoft and to bring the power into a very similar environment, user configurable, that allows us to bring in commercial data. It's a two-way operational interface between the sets. Data governance is very important here. And then also a feed from OSIsoft from the historical part into PowerRunner's forecasting engine. But what's interesting is that the network that we're moving into is we go from static to dynamic. Down on the distribution grid, there is so much more activity, so much movement from feeders to recircuiting to just just the smart meter themselves, the change in, change out. You could have hundreds and tens of thousands of meter changes in a night. How do you keep your topology up to date and to be able to do your roll-ups with confidence that this is the network topology? And that's what we're doing together, Pi and PowerRunner, to drive that value. And that's the baseline. Once you have that topology baseline down, everything else is accurate on top from the use cases. And Dan will go through some of the use cases that we're doing together. About 18 months ago, the vision is that smart meters are going to be the next, level of SCADA. There's utilities out there that are moving to their second generation of smart meters, communication, and head-end systems. They're going from a latency of 24 hours, being able to collect it on 24 hours or 3 times a day to 5 minutes. That's where it's all heading. That's going to be really important for operations to get their hands on that data, especially the voltages and other information to help keep the grid running and keep the resiliency. It's the furthest eye on the network, and if you can capture that, you got vision across your entire network. So we worked with Amarin on how do you reduce the latency of smart meter data into operations. At that time when we started this proof of value, it was taking roughly 36 to 48 hours going from the head-end system to the MDM into their process and flow into their enterprise data warehouse to make it available for operations. But as we all know, operations works in real time, near real time. That really wasn't cutting it. So what we looked at was like, well, why don't we look at Pi, right? Pi has a high ingestion rate. Let's grab the data from the head-end system as soon as it gets there, and then bring it in the PowerRunner adapter to add more data around it and drive value from an operations perspective. So what we did is basically pulled the head-end system into Pi. The pilot started off about 10,000 meters. We ended up doing over a million meters at a time with about 4 to 5 attributes per meter, bringing it in. I think it was every 8 hours it was pulling in. So we were always bringing it in. And as soon as it hit OSIsoft Pi, and we got it into the PowerRunner platform, we reduced the latency from 36, 48 hours down to less than 90 minutes to have that data available in operations. The choke point on this, again, was the head-end system. It's just the way it was designed. But as I mentioned, they're designing to bring in real time. We've worked on pilots where they would carve out sections of their system and put 5-minute capability, and we were pulling back voltage information on a 5-minute level into operation. That's where the industry's going. That's where the technology needs to go, and that's where we're going with OSIsoft and PowerRunner. So as we go, most people know it's deep asset analytics of the Pi system. We've got the real-time ingestion. We've got the capabilities of the time series data. We bring contextual information to that with the AF layer and analytics, notifications, event frames, and then the visualization of that. To expand that, let me see if I can go back one more. It's not clicking. Let's try it one more time. There we go. Now we're broadening it. We need to connect OT data with IT, and then we need to have a very high-performance, scalable technology working with Pi so we can connect the customers, so we can bring OT and IT data sets together, and then mix the data sets from OT and IT, from financials and operation, and drive the value to the end customer. And with that, I'm going to hand it over to Dan. Hopefully I laid the groundwork of where we're going, what our vision is, but I do want to give a shout out to partners such as PowerRunner, because Pi has a large partner network that we work with. We actually go from system integrators to PowerRunner type application providers, technology providers, value-added resellers, and OEM. So, they enhance your investment in the OSIsoft technology, and we thank them for that. Dan?
Okay, Kevin, thank you. That was a good presentation, a good setup for us. I'm going to just take a few minutes and sort of comment on some of your slides. You'll see as I go through the PowerRunner presentation that there's a lot of complementing technologies. And what I hope you'll understand is that the PowerRunner on top of Pi actually extends the value of Pi data to the enterprise, not just within operations, but beyond. So I'm sure many of you are more familiar with OSIsoft than you are with PowerRunner. So if I may, I'll take a few minutes to run through a quick little overview of PowerRunner, who we are, our experience. So the principals in PowerRunner have decades of energy industry experience. As from my intro, you saw that I cut my teeth in the utility space years ago. Many of my colleagues actually worked in the central market as central market architects. And PowerRunner originally was formed in 2007 to work on the formation of many of those central markets, CalISO, ERCOT, MISO. Around the same time, too, I think that's the era of the ARA money and the spending. We could kind of say the origin of the smart grid back in the 2009, 2010, as a lot of spending in smart grid, smart meter investments began. Like Kevin outlined, initially a lot of those investments were, reducing truck rolls, no longer needing meter readers, and no one really had a focus on, operationalizing AMI data. Here we are 10 years later, we're still, many companies are struggling with operationalizing AMI data. And I think the PowerRunner Pi solution actually can demonstrate how grid ops can utilize this data in near real time for support. So we have over 20 in production solutions already at utilities, energy companies, retail energy companies across the states. And I'll touch on some of them today. What I want to do today is just sort of walk through, again, to continue the overview of PowerRunner. We'll talk about our technology. And, Kevin's highlighted the data virtualization layer at this point. But we also have a pretty robust predictive analytics platform for load and generation forecasting. We've come out with the next generation of predictive analytics using GPU processors, and we'll touch upon that as well. And similar to Pi and Kevin's statements in his presentation, is that we want to make this a self-service analytics platform. PowerRunner is, and we think that we need to push the power of data into the subject matter experts' hands. So there's a common parallel between our two solutions. And then, looking at the systems and the solutions that we build, we refer to our solutions as a system of systems type solution because we are gathering data from a lot of disparate sources. So in this case, we'll talk about the OTIT joining today, again, making it configurable with the business users. And, one thing Kevin didn't emphasize is that PowerRunner is not a database. So we have a very low footprint, and the implementation of our solutions is pretty quick and scalable and extendable across the enterprise. So let me sort of jump into the sort of data governance and data management perspectives that Kevin was talking about. The PowerRunner platform really consists of, the ability to create trusted and actionable information. So if we're looking at joining OT and IT, you're really looking at two different types of data sources. Some of it might be time series data, some of it might be scalar, but definitely OSIsoft is pulling in the streaming data. And I want to emphasize over here on the left that like Kevin mentioned in his presentation, AMI had for the last decade really been an IT focused type of data source. What we're saying, and what we demonstrated at Ameren with that pilot, is that we can pull AMI data directly into Pi and utilize it for operational purposes. So this will be the focus of my discussion today, just really looking at streaming data from Pi into PowerRunner for essentially grid ops, the use cases that we're going to walk through today. So from a data management standpoint, you've got data coming in megawatts, kilowatts, all different, scales. So we need to normalize that data. We need to align that, sub-second data with 15-minute and hourly data. And we always need to understand the relationships of the data. So meter to transformer to substation. All of that has to be maintained and managed in a common platform. And then obviously, there has to be some governance around the data. So a role-based security application. And, we're always like like Pi, we always effective data in our system. And we create different versions of data so that we can always go back in time and look at timestamp data from previous days, months, weeks, and the relationships between those data. So not just the data itself, but the attributes of the data at any previous point in time. So auditability and traceability is also key as well. So we have all of this built into the PowerRunner platform. I kind of look at this as creating the trust, right? We've got one platform where all the data is, some people refer to it as democratized. However you want to refer to it, it's all normalized and secure in a common platform. And again, these are snapshots of data. We're not a database. We're not pervading the data. But once you've got the foundation of the data in place, you can now look at, the analytics that you want to apply to that data. So inherent in the PowerRunner platform is a calculation engine. And this calculation engine applies to, can perform calculations at the data measure layer. So in other words, at the meter, at the AMI meter. Anything from simple math to logarithmic functions, they're all in there. Very robust calculation engine. Our forecasting engine, I'll touch on this a little bit later, but it's unique in that it's it creates unique creates unique forecast models for each service point. And then the network model manager is kind of a rules-based data algorithm that we'll walk through as well. So I want to separate the difference between, utilizing streaming data from Pi and other analytics that you might see in other types of platforms. In this case, we're talking about inline processes. In the case of the three use cases that I will go through today, they truly are inline processes. And what I mean by that is they're continually running. Once they've been set up and organized by the SME, configured by the SME, they simply run and feed other processes. So our day ahead load forecasting, our network model manager, these are examples of inline processes. You can also set up in PowerRunner the inline data limit notifications. So this is a difference where this is a continuing process, the inline system processes, in a continuous process where we are constantly examining the data that streams in from Pi to check on limits of downstream transformers or any violation. So if we're aggregating meter load up to a transformer, we can send a warning at any time when that limit is being approached. And this is, again, all configurable by the subject matter experts. Clearly, if something arises out of one of these notifications, because the data is built on top of the AMI, we can dive down and do a deeper dive into the data to understand what the root cause of some of the problems are. So, for instance, if all of a sudden, you've got a transformer that's exceeding load, you know what, maybe two people bought a Tesla in one neighborhood and now we're overloading a transformer. These are the sort of things that you may not discover unless you have this sort of filter in place that actually rolls up the problems to the users. So the other sort of use cases, again, these are more offline. And when I say offline, I don't mean outside of PowerRunner. but not using streaming data. It's really about doing some planning and sandbox analysis, especially as you want to look on a more localized level for planning. You need to understand what the potential is for multiple scenarios. The proliferation of EVs, more solar. What are the different changes going on in the system that you need to actually run multiple scenarios for? This can all be done in PowerRunner. And analytics and dashboarding, clearly we've got the capability of do this, or we can push this out to a BI tool if there's a preference for some other platform. So today we're going to talk primarily about these three use cases: the network model validation, the real-time loss analysis, and load and generation forecasting. I've separated out the meter data analytics because truly this is a toolbox that comes with PowerRunner out of the blocks. This is really analytics tools that are going to be foundational going forward. I think almost every grid ops team is going to need to have these capabilities in their toolbox. So looking at these three use cases, validation, network model validation. The importance of this clearly is understanding the relationship between assets. We'll go through this in a good detail in a few next slides here, but if the system operators aren't confident in the model, then decisions made can be affected. And so, again, this is one of those continual processes that runs on a nightly basis and continually improves the model over time. So the real-time loss analysis, this is an automated process as well. It runs on a nightly basis in production at Ameren, where we are running calculations across the system and posting a loss factor for the next 5 days out into the for retail energy suppliers to use. And then we'll talk about load and generation forecasting, and then specifically the benefits of using forecasting with GPU service. So jumping into the network model validation. This particular example is using, hang on one second, using a GIS feed for the baseline of the relationships between assets on the system. And we're doing a voltage comparison of the profiles of grouped meters on a particular transformer. So if we look at the relationships that we have here now, we have about 328 transformers behind this one substation, and about 2676 meters, but we found 13 violations on this particular circuit. So the intent is to now analyze how we get these, are these violations valid, and how do we sort of prove them out? So the intent here is to sort of walk through this process where we show this screen here is more for analytics purposes. This is running automatically in the background, but if someone needs to drill in and actually look at the data, they can look at the comparison of the actual meters and their voltage profile to the transformer voltage to identify where the actual variant load voltage profile exists. So we then take this and we run this through a comparison where we are trying to actually determine what may be the best adjacent transformer to reassign this meter to. So we use a geofence, and this one here happens to be 0.1 kilometers, so 100 meters away from any of the original transformer assigned to the meter. And then we actually will evaluate all of the all of the voltage profiles for the surrounding meters to come up with the best fit on a recommended meter or recommended transformer. So using the profiles, if you went in and looked at this and did the analysis, you could see that the original meter voltage profile more closely follows the recommended transformer voltage profile. So this was a pretty impressive out-of-the-box results here with this analysis. We got about a 90% out-of-the-box validation of errors on the initial read of meters outside of variance. And then we had an 80% accuracy of the recommended transformer assignment. So we validated this, the utility we're working with to do this, actually validated this by rolling trucks and doing a visual assessment of this. So it is quite impressive to do this out of the box. And the fact is that, you know, even 90%, they would like to reduce some of those, you know, false positives to 2 or 3% if they could. So we're continually iterating through the network model validation process to mitigate the false positives. There are all sorts of controls that a operator can tweak to essentially improve this performance. I don't have the time to really go into that today. We only have a limited window, so if someone has more questions about how that is operated, we can actually talk about that later. But the key is that the improved model actually is providing confidence to the network operators or the system operators to essentially improve the VVO performance, the DER integration, and any sort of switching that's going on downstream. So I'm going to talk a little bit too about the real-time loss analysis use case. This is specifically done at Ameren. There's a good IEEE presentation that it was done about 1.5 years ago. If you want to look it up, it's, you know, if you just did real-time loss analysis, Ameren, it should come up. But Ameren was about 1.5 years into their AMI rollout, probably about 80% done. And they were looking for ways to actually utilize this data for operational analytics. And this was one that actually rose to the top because they had a pending filing that they needed to submit to the ICC. So they reached out to PowerRunner and we conducted this real-time loss analysis. So, you know, part of the reason why they needed to go down this path was because as they were rolling out their AMI, they began to reduce the profile error, which is greatly associated with UFE, unaccounted for energy. So they needed to properly allocate that across the customers. And in doing that, they also were able to reduce the volume risk and price risk to customers, and more importantly, the energy suppliers serving those customers. So we developed a process where we are publishing the loss factors to the suppliers on a daily basis. This process was actually approved on a fast-track basis with the ICC in less than 2 months. It was well received, obviously, by their staff. So from an Ameren perspective, though, this freed up a lot of resources. It's a time-consuming process to run through an AMI, to run through a loss study. And these are valuable resources, too, that needed to be focused on other high-value use cases. So, and they also see this from a forward-looking, benefit of being able to help them with some of their grid ops. So I realize I'm running late on time here, so I'm going to try to speed this up a bit. A little bit of the AMI data ingestion into our micro forecasting engine to create these day-ahead load forecasts, both by a grouping of secondary system loads and individually primary and high voltage and transmission customers. By the way, we're ingesting over 2 years of data on a nightly basis for over 1.5 million meters. That's 25 billion hourly reads that we're pulling into PowerRunner to actually make these calculations. The initial results was obviously we needed to create that day-ahead load forecast, which by coincidence actually reduced their MAPE by 30% over their incumbent system that had been using a top-down load forecast process. So running this through the loss calculator, which is a complex calculation, which again is in that presentation that I referenced, we were able to create loss factors for each of the voltage classes listed here, and we pushed this out onto a retail website. So you could go to Ameren today and look at their day-ahead load forecast. You could look at the load factors published F1 through F5. We do a 5-day look ahead. So in this case, I actually took yesterday's, you can see 526, the F1, which is today, loss factors across each of these voltage classes at Ameren. So Ameren, Illinois loss factors for today are as follows. So where are we? 10 a.m. there. So here we are right there. So let me jump ahead to the next generation of load forecasting, which is actually to take the forecast engine that we are currently utilizing on CPUs and port it to a GPU platform. So we worked with our partner, NVIDIA and Dell, to actually test this out, and from a proof of concept standpoint, we were able to take over 2.5 million meters and run it through the NVIDIA cards and actually reduce the time it takes to run hourly load forecast on 2.5 million meters from 80 hours down to 1.5 minutes. So that's pretty impressive. From a situational awareness perspective, as Kevin mentioned earlier, even though data latency may be actually reduced and data latency might be coming down to even 5 minutes, the fact of the matter is grid operators need to see 15 minutes to an hour ahead. So we need to be able to run forecast in near real time based on the data the best available data that we have. And this is what we see the future of situational awareness looking like, where we're streaming data in from the PI system, cleaning it up in the virtualization layer of PowerRunner, utilizing our streaming I/O engine to run forecast through a GPU optimized forecasting engine, and then pushing those forecasts out to either a control room where they're looking at predictive analytics, or we are just simply dispatching prescriptive analytics measures. So, you know, run a battery, you know, fire up a demand response program. All those sort of things become more prescriptive based on AI that's developed in near real time. So if you take that scenario to the next end, you know, this is a probabilistic sort of scenario here where, you know, Kevin mentioned earlier that Pi is becoming kind of a, you know, virtual SCADA point, or I should say AMI data is becoming a virtual SCADA point. And if we're pulling that data through Pi, then we have the ability to create multiple probabilistic looks of what the system might look like in the next 15, 20 minutes. So if we look at this scenario in a steady state, you know, this might be a non-wires alternative scenario where there's a capacity constraint at a particular substation, and, you know, DER has been deployed downstream to help mitigate that. Well, that makes operating this system a little bit more complex because you're dependent upon the operation of downstream assets to keep that system from overloading. So in this scenario, if we get a cloud bank that rolls through, you do irradiance, you may lose half or more than half of the generation on your system. So that's an increase in load that's happening in real time. Well, you need to know how to respond to that in a bidirectional world here. So in that scenario, you got to have some prescriptive transactions that just kick in. So maybe there's a bilateral contract and this DR response kicks in and you get 350 or you got 300 of the 350 lost in that one swoop, but that's not enough. So you need to deploy some controllable loads. You need to, dispatch EVs and, or, draw on EV charges and whoop, went too far, sorry guys. Those are the sort of things that I think you need to be thinking about in the future from an operational standpoint. So sorry, I'm skipped ahead to this slide, so I'll just stay with it. So to just summarize what we've talked about, and again, I've hit a lot in the last 20 minutes here. We're trying to create situational awareness from AMI data, and the PI infrastructure, the scalable data infrastructure, is foundational to that. And then you got to have trusted data to actually work with, and then the business analytics that puts this actionable information in the hands of the subject matter experts. So this is what PowerRunner and PI are working towards. We believe that our solution can actually deliver all of this functionality and is a scalable solution that can meet some of the use cases that we've outlined earlier, that we've demonstrated here today. And these use cases, sorry, my slide can't advance here, guys. Oh, there we go. And Kevin, are you playing with the slide? All right, there we go. So these are so these are some of the use cases that we've talked about today, but these are the use cases that we see serving the grid operations teams in the future, and what we can do on PowerRunner and PI using OT and IT data. So sorry, I went fast there because I was running out of time and needed to leave some time for questions. So Lauren, I think we wanted to sort of turn this back to you at this time.
Yeah, great. Thanks so much, both Kevin and Dan. So we have quite a few questions coming in from the audience, and we will do our best to get to as many of these as possible today, and we'll just go right in. So the first question that we have from the audience, why do we need GPUs?
I'll let you take that one.
Yeah. Well, the value of GPUs is really in processing enormous amounts of data. When you start to think about the data that we are ingesting from AMI, we're talking about billions of data points. And if we want to run forecast across every possible every service point on the system and run multiple scenarios. So for instance, what if the temperature drops 5 degrees? What if the temperature rises 3 degrees? What if the cloud banks come through? So again, it comes into being able to run multiple scenarios over using massive amount of data in very, very short windows, because as situations are changing, that last sort of busy slide that I was running through is the example. As situations begin to change on the ground, you need to run through scenarios in near real time to project what's going to happen in the next 15, 20 minutes, hour, whatever that may be. I'll give you a classic example of a problem that's occurring, and you guys may know about this in Hawaii right now. They actually have a cloud banks that come through and knock out some of their solar, but by the time they ramp up their standby generation, or I should say their peakers, they've got some gas peakers or oil peakers, the load has already come on and off. And those sort of scenarios, if the grid is going to be that variable, you need to be able to predict what's going to happen, or at least have some multiple scenario in place over the next 15 to an hour. I hope that answers the question.
Thanks. Yeah, I think that was great. Thanks, Dan. So our next question is regarding inline processing. Can this be utilized to control midline rigs and caps in the same way that VVO optimizes VAR and reduces voltage?
Hey, Dan, I'll take that one.
Great.
Yeah. Well, first of all, neither one of the technologies we've been talking about today, OSIsoft and the Pi system, and the PowerRunner technology are control systems, all right? But that being said, there's no reason why, if you're looking to generate set points and conditions, because we're pulling all this data in near real time and it's a variety, and we're correlating different data sets, and to be able to do analytics upon it to drive that set point or that information you're looking for to send it upstream. We have clients from the OSIsoft side today doing that, but OSIsoft is not a control system, nor is PowerRunner.
Correct.
All right, great. So the next question from the audience, is your software installed in the end user server and the end user server can configure and customize the way they want to present the data? Or will you make a remote connection to the MDM and manage the data remotely?
Hey, Dan, I'll take the first stab at it.
Yep.
I would say from an OSIsoft perspective, this is an on-prem software package, so it's typically on-prem. What we would do, and this is kind of similar with PowerRunner, and Dan, keep me honest here, even though we do offer SaaS solutions, because of the data set and the volume of the data set and what clients want, it's definitely an on-prem install. There's a configuration of just interfacing, standing up the infrastructure, meaning relationships, tables, the AF structure, and then from there, once the configuration is done, the end client, through training themselves or a combination of themselves, training and partners, can then manage the analytic layer and the business user layer to drive these use cases from that point on. Dan, you have any comments?
Yeah, I would actually just echo exactly what you said there, Kevin. I mean, we do have a cloud offering. Some of our clients actually, non-utility clients actually do use it in the cloud. So it's the same product, but, due to the fact that we are touching operational data and highly sensitive, NERC-CIP type of compliance issues apply here. So we generally install on-premise, and we can, teach the man the fish is sort of, our strategy as well. So we do the initial configuration and setup, but it's highly configurable after, and power users can get in there and do, a lot of complex configurations, complex calculations, stuff like that.
All right, great. Thanks so much. So our next question, what exactly is a quick implementation? Can you provide a better idea in terms of weeks, months, years, et cetera?
I guess that one would be for me, Kevin. So I would say, I don't think we've had an implementation that's lasted more than, 12 weeks. We are, some implementations, in all honesty, can be 6 weeks. And I think, if we're talking about integrating with a customer that already has most of their AMI data or any data set in Pi, we're probably looking at the lower end of that scale. And every project is unique in that every project has its different integration points, and but I'm very comfortable in talking about the numbers that I just sort of put out there.
Yeah, and from the OSIsoft side, that's what we take pride in. We're definitely not years in the development. We're more, weeks to months. But both these technologies, I like to kind of equate them to like their weeds. Once they get rooted, and once you get your baseline infrastructure set up, building I would call it the applications or the analytics and the visuals is pretty quick. And that's what we pride ourselves on. Both we want to, we don't do, at least OSIsoft, turnkey. We do installs and then we train and then they build and then over. So it depends on number of kind of PI applications or projects you want to do, but getting the baseline in and getting it started and running is definitely weeks to months. We're typically not the holdup in the project, we'll put it that way.
Great, thanks. So we only have time for a couple more questions here. So the next question, is PI providing the network model information, or is there a need for a GIS interface?
That's really customer specific.
Yeah.
Go ahead, Kevin.
Good point, Dan. No, go ahead. Exactly.
Well, it's really customer specific. We've actually had it flow both ways. So it's a matter of whatever the customer's preference is. I mean, Esri is the leader in that space, and PI and Esri have a tight integration. So generally, there's no sense for us to create a second integration layer if it's already in PI. So, Kevin?
Correct. But if it's in PI, it's typically we're not the database of record of that. It's being fed from another system. But we actually leverage the PowerRunner technology to keep our AF structure. I don't know if you're familiar with it. There's the PI archive, and there's the AF structure, which is the metadata layer, which we house a variety of different kind of structures, from hierarchical to the network topology. If it's based on SIM, it really doesn't matter. But to have that updated in a systematic way, especially when we get down to the meter space and what's happening with that, that's why we had the AF SDK connector between the two systems. And we could leverage it on the PowerRunner side if they're actually orchestrating the network topology and keeping it all in sync from a company's point of view, or if there's another system, we can ingest it that way. But one of the earlier points I mentioned was the data governance, right? It's extremely valuable to keep the data, the versioning of that. So if there's a system that's keeping the versioning of the network topology and updating AF, there's one, but we're leveraging and looking at PowerRunner for that to keep all the systems in sync, especially PowerRunner, and then actually keep the data, the records of it. So if a planner wants to go back over time and extrapolate what that exact network topology was with the relationships and go look at the data information surrounding, 30 days ago, 40 days ago, we're leveraging PowerRunner to have that capability or have that capability. And actually, that's a good point because we may not be thinking about it today, but I know around the world, the distribution operators are turning into distribution network operators, right? And so if you think about what's happening on the transmission grid, it's not static. There's moving, there's data, there's validation, and the versioning of that. And so if that market moves down into the distribution space, we want to have that capability. And then PowerRunner really has a strong and powerful data governance, data management environment in it.
Great. So the next question, and I'm afraid this is the last one that we're going to have time for today. In the current installations, what is the frequency of the AMI data in terms of the voltage data sent to the OSI model from VVO? Also, what is the interval data length?
So the frequencies will vary by the utility. As a matter of fact, the example that I was going through actually, because the utility only had hourly data in there, was only capturing hourly voltage data, they're going through the process now of actually updating all their meters to bring in 15-minute data. So in that scenario, we're actually capturing 15 minutes and hourly voltage data across that utility. So as they convert or they have to reprogram the computers, the transformers, meters, and as they reprogram them and we start to get 15 minutes in, 15 minutes will become the de facto standard. And I'm sorry, there was a second
right.
half of that question.
Yeah, Dan, let me add a couple comments on that, if you don't mind. Is that okay, Lauren?
Yep, that's great.
So the OSIsoft technology, prior to the relationship with PowerRunner, we were ingesting 5-minute voltage data for operations, bringing that in. And again, you know, Pi is a sub-second real-time data ingestion, has data ingestion capability. So it's really depending on the systems that we have to integrate into, and as we mentioned earlier, the head ends capabilities. But I know most metering manufacturers are, you know, head end system AMI manufacturers are really gaining and focusing on bringing that latency down, and it's going to become more important for grid operations.
All right, great. Thanks so much, both Kevin and Dan. Unfortunately, we have run out of time today. I want to thank everyone for attending the webinar. And I want to remind you that the webcast will be on demand and will be available on the T&D World website as well as the OSI websites. The link to the recording will be sent to you via email within the next 24 hours. As well, for those questions we did not get to, our speakers will be going through those and answering them on a one-on-one basis in the coming days. So with that, I want to thank everyone so much for attending and have a wonderful remainder of your day.